Kepler 186f is one of the most famous planets ever discovered because it gave scientists something they've been searching for a long time, an Earth-sized world sitting inside the habitable zone of another star. That sounds like good news. A planet roughly similar in size to Earth, far away in space, orbiting a small red dwarf where liquid water might be possible. But now imagine something much stranger. Kepler 186f is suddenly gone, and Earth takes its place. At first, this sounds like Earth has been moved to another possible home. It is not floating in empty space. It is not falling into a black hole. It is not being burned beside a blue giant star. Earth has arrived at a system where scientists once thought a rocky planet might survive. But that is where the comfortable part ends, because the habitable zone is not a magic safety ring. It only means the distance from the star might allow liquid water under the right conditions. It does not promise a friendly sky, stable weather, healthy crops, working satellites, or a civilization that can keep functioning. The first disaster would be psychological before it becomes physical. The sun would be gone. Every sunrise in human history, every calendar, every season, every shadow, and every living system on Earth evolved under one star. Now that star has been replaced by Kepler 186, a much smaller and cooler red dwarf. The daylight would immediately feel wrong. It would not have the same brightness, the same color balance, or the same energy that Earth's life is built around. People look outside and see a world that still has oceans, mountains, cities, and clouds, but somehow no longer feels like home. And this is where the science becomes uncomfortable. Kepler 186f orbits much closer to its star than Earth orbits the sun. NASA lists its orbital distance at about 0.432 Australian dollars, which means less than half the distance between Earth and Sun normally. That would sound like a recipe for destruction, because if Earth moved that close to our Sun, the oceans would boil and the planet would become unlivable. But Kepler 186 is not our Sun. It is an M-type red dwarf, cooler and dimmer, so its habitable zone sits much closer in. Earth would be near the star, but not necessarily warm in the way we expect. That is a strange trick of red dwarf systems. You can orbit close and still receive much less useful light than Earth gets today. Kepler 186f takes only about 129.9 days to complete one orbit, so Earth's new year will be roughly 4 months long. Human calendars would collapse overnight. Agriculture would lose its timing. Migration patterns would become confused. Weather models would become useless. Every system that depends on Earth's normal year would be outdated in a single morning. But the real problem is not the calendar. It is energy. Earth's biosphere runs on sunlight. Plants, algae, plankton, forests, farms, and food chains all depend on the kind of light the sun provides. Around Kepler 186, Earth would receive light from a cooler red dwarf, meaning the energy reaching the surface would shift heavily toward red and infrared wavelengths. Some plants can use red light very well, but Earth's entire biosphere is not designed for this exact stellar environment. The oceans would still be there, but the tiny organisms that feed marine life would face a new world almost immediately. This matters more than it sounds. If phytoplankton struggle, ocean food chains weaken. If crops struggle, human food systems weaken. If forests grow differently, carbon cycles change. If the planet receives less energy overall, ice begins gaining ground. Earth might not freeze instantly, but it could begin moving toward a colder, darker climate. The scary part is that civilization would still be alive while this happens. People would still have electricity for a while. Cities would still glow at night. Governments would still speak. But the planet's engine would be changing underneath them. Then comes the satellite problem. Earth's satellites would not all fall from the sky, just because Earth changed star systems, because many orbit Earth directly, but the systems behind
Sunlight
them
from
would
the
be in
sun
chaos.
strikes Earth's surface.
Solar power
As
output
ice
would
expands,
change
it
because the
reflects
sunlight
more
is
energy
weaker
back into
and
space.
different. Deep space
This is the
communication
albedo effect,
references would
which
be
helps cool the
destroyed.
planet.
Star trackers, navigation models, astronomical databases, and space mission planning would become useless. GPS could still function locally for some time, but the entire global space infrastructure would be operating in a sky it was never designed for, and the moon would become one of the biggest questions in the entire scenario. If Earth replaces Kepler, 186f of the moon still attached, then Earth keeps its tides, its familiar companion, and some stability in its axial tilt. That would be the better version. But if Earth appears alone without the moon, the consequences become much darker. The moon helps stabilize Earth's tilt over long periods. Without it, Earth's climate could become more unstable over deep time, and tides would become far weaker. Coastal ecosystems, ocean mixing, and biological rhythms would all change. Even if the moon comes with us, the night sky will be completely rewritten. Every constellation would disappear. Orion, Ursa Major, Cassiopeia, the Southern Cross, all of them would be gone or shifted beyond recognition, because Earth is now hundreds of light years from where those patterns made sense. Astronomy would not just become difficult, it would become emotionally disturbing. Humans would realize that the sky, one of the oldest maps in our species' memory, no longer belongs to us. Now the big question is whether Earth would stay warm enough. Kepler 186f has often been discussed as being a habitable zone, but near the cooler outer side of that zone, if Earth receives much less stellar energy than it received from the sun, temperatures could drop, ice sheets could expand, snow would reflect more, light back into space, causing more cooling. This is called an ice albedo feedback, and it is one of the most dangerous climate traps a planet can face. More ice creates more reflection creates more cooling, and more cooling creates more ice. Earth does have a powerful defense. Its atmosphere. Greenhouse gases trap heat, and Earth's oceans store enormous amounts of thermal energy. That means the planet would not become a frozen ball overnight. The oceans would resist rapid cooling. The atmosphere would keep moving heat around. The tropics might remain livable for a long time, but the edges of the world would begin changing first. Polar ice would expand. Winters would become harsher. Growing seasons would become shorter. Food production would become the first major human battlefield. The producer-style twist here is that the biggest danger is not instant death. It is slow survival. Earth might survive the move, but human civilization could start breaking under the adjustment. We are not built as a species to calmly redesign global agriculture, energy, navigation, economics, and climate strategy under an alien red star. The planet may remain physically alive while human systems begin failing one by one. And red dwarfs bring another problem. Many red dwarf stars can be active, especially when young, producing flares that blast nearby planets with radiation. Kepler 186 is not the most extreme red dwarf known, but living close to a smaller star always raises the question of stellar activity. Earth has a magnetic field, which protects us from charged particles from the sun. That protection would become even more important in a red dwarf system. If strong flares hit Earth often, satellites could be damaged, power grids could be stressed, and the upper atmosphere could be disturbed. Here is where things get even stranger, because Earth would be much closer to Kepler 186 than it is to the sun. The star would appear large in the sky than people might expect for such a small star. It would not look like our sun, but it would dominate the sky in a different way. Sunrise and sunset would become redder and dimmer. Days would feel less sharp. Solar panels designed for the sun would produce less power, forcing humanity to rethink energy at the worst possible time. Nuclear power would become more valuable. Geothermal energy would become more valuable. Stored fuels would become more valuable. Countries with strong energy infrastructure would survive better than countries dependent on fragile systems. Food would move indoors. Greenhouses would become national security assets. Artificial lighting would become as important as farmland. The richest countries would try to protect their food supply first, and the poorest regions would be hit hardest. That is usually the hidden part of space disaster stories. The planet changes, but humans do not suffer equally. A colder Earth around Kepler 186 would create new winners and losers. Some equatorial regions might become more important because they stay warmer. Some northern regions could become harder to inhabit. Ports could freeze more often. Crop belts could shift. Governments would fight over energy, food, and migration. The cosmic event will become a political event very quickly. But Earth is not helpless. This is still Earth. It has a thick atmosphere compared with many rocky worlds. It has oceans. It has an active geology system. It has life that has survived ice ages, asteroid impacts, supervolcanoes, and mass extinctions. Microbes would adapt fastest. Some plants would adjust over generations. Humans would use technology to force survival where nature becomes difficult. The planet would not simply give up. The most interesting possibility is that Earth could become a different kind of living world. Not dead, not familiar, but changed. Forests might thin in some regions and expand in others. Ocean ecosystems could reorganize around species that handle the new light and temperature better. Human cities might become more enclosed, more controlled, and more dependent on artificial environments. The surface would still be Earth, but the lifestyle will become partly planetary and partly space station-like. The biggest long-term question will be whether Earth can maintain stable liquid water. If the greenhouse effect is strong enough and the atmosphere remains healthy, oceans could survive. If cooling runs away too far, sea ice could spread across much of the planet. If the planet enters a snowball state, life would not necessarily disappear, but complex civilization would face a nightmare. Humans could survive in protected zones, underground habitats, heated cities, and controlled farms, but the open natural world will become far less generous. And remember, Earth would now be 500 plus light years from home. There is no rescue mission coming from the old solar system. Even light itself would take centuries to cross the distance. If Earth vanished today, any signal sent back toward our former neighborhood would not arrive for hundreds of years. Humanity would be completely isolated in a new star system, surrounded by alien planets, with no way back. That changes the emotional weight of the